Hi, I'm Sam. I'm English, hope that's okay. I come from the University of Cambridge, and I try my best, I'm getting feedback from the system here, stand back. I try my best to make things as simple as possible. The reason I do that is because I've been working in education. But I'm going to explain to you why I think that's actually a really important thing for a large range of different things. I built this thing called Sonic Pi, which I'm going to show you in a moment. But it's worth just trying to set the scene, right? Because this is like a stadium here where somebody's, that's me actually, performing music. And the thing is, when you go and see people perform music like this, maybe they've got a laptop out, you've got no idea what they're actually doing. And I mean, am I reading my emails? Have I got an Excel spreadsheet open? It's really hard to know. Like, and if you've got a musician, are they actually pressing play, standing back and watching it happen, but pretending to do stuff, or are they actually doing it live? Now, the cool thing about this show is that, and I mean, I'll show you how to do all this stuff, is that we had a big projection like this screen here on the outside, which is showing my screen, right? So we actually mirrored the screen, and on the screen is the code I was writing to make the music that people were listening to, right? So this is my office. That's my desk, standing desk. So I'm actually making music by writing code. And I'll explain more about exactly what this is and why it is. Now, I don't know, who here has written code to make music before? Oh, a few people. That's pretty cool, right? Hopefully, actually, at the end of this session, you'll all be super excited to go home and download this thing and have a go yourself. But in the early days, I worked in a system called Overtone with a friend called Jeff Rose. Let's see if I can find the website. There we are. This was pretty fun, right? So it was a Clojure-based environment, so it ran on the JVM. It was me as a programmer with my wizard hat and staff, right, being Gandalf. What is the most powerful programming language I could possibly build as a programmer? Because obviously that's the way to go. And this is my attempt to do that, and it was pretty fun. And you can see here, that's me and my brother-in-law, Jonathan. We're performing here. This is actually in, where was this? This was in Berlin. And we made a band called Meta X, and we performed on stage. But the code and the system was so complicated that every time I performed, I had cold sweats. And I had to open Emacs and open the JVM and connect processes that connected to each other. And all the time, right, it never really properly worked. It was just too complicated. Because if you're sitting at home and you've got, I don't know, 10 minutes to set it up, right, you can do that. It's not hard. You just take your time. And if it's going a bit difficult, you go and have a cup of tea, come back. But when you're in front of a big audience, you don't have that luxury of that time. It needs to work now, right? And so the stress of this environment was too much. And also, performing with it, writing the code, because the constructs were powerful, we always talk about language X is more powerful than language Y, right? Why is this? Because I can express these things in language X, and you can't. Well, you can express in language Y, but it's really like lots of words, and it's not very nice. And when people talk about these things, they rarely talk about how long it takes to actually code the solution, right? Just because you can code a solution elegantly in language X, that might be fine, but maybe that took you 5 weeks to come up with the idea, to come up with the abstractions, to come up with the solution. You know, and maybe this language over here, which is more complicated and not as nice, but maybe took you a day. Like, okay, so one might be more elegant than this one, but which is better? Well, it really depends, really, on the context. And when you're making music live in front of an audience, things which take less time typically are much better, much more useful. And so this system I was working on, this overtone system, was too complicated. It just took too long to code things. And mainly because the abstractions I chose were aiming towards power, but in a timeless way, where it didn't matter how long it took to build something, as long as I could build it. But when I was performing, I soon realized that time was essential. So anyway, I'm building the system, working on it, I'm performing, I'm going around the world, making music with it. It's huge fun. And then these guys came along, which came out of the University of Cambridge Computer Laboratory. It's the Raspberry Pi Foundation. I don't know if you can see on the screen. It's gone. There we are. This is their website. And they made this little tiny computer. You obviously heard of the Raspberry Pi, right? So the people with the Maker Faire tickets are probably going to go and see people building all sorts of crazy stuff with the Raspberry Pi. And the thing was, this computer was so successful that it caught them by surprise. They had no idea that it was going to sell so many. They've sold almost like 15 million, maybe more, I think, at this point. And so they were flying out the shelves, but there was no real software to support their charitable mission, because they're a charity, right? And their mission is to broaden the usage of computer science. It's to try and get more people involved in programming from a really diverse range of audiences, and particularly children. And so there wasn't that much software on this system that could really engage kids in code. And so someone came along the lab saying, we've got this small amount of money that perhaps can get some researcher to spend a few months possibly asking this question, can we get kids coding with this Raspberry Pi? And I was like, hi, I do this music thing called Overtone, maybe I can make a really simple version. And so I built, actually I've got it open up here, this thing called Sonic Pi. And that was 5.5 years ago, 6 years ago, and I'm still working on it full time. And so we're going to see what it can do now from what it could do then. But its goal, right, its goal is to be simple, powerful, free, and we want to really try our best to make the range of people using this system as diverse as possible, right? And that doesn't mean the typical notions of diversity that we always talk about, which are extremely important. It also means non-programmers, really, people who wouldn't even be interested in programming. Like, how many of you are interested in programming? Not many, actually. I think that, maybe I can't see. Most of you, to be honest. Now, that's cool, right? And probably in your homes, when you were young, you just found computing, you found programming languages, and you just toyed and experimented and tinkered and played, and you got excited by the things, and you read a lot, and you learned a lot, and you applied all that knowledge, and then you got a job, and now you're all here, sitting here, right? And probably that's a story that would resonate with most of you. Now, if we want to reach out to a broader set of people, perhaps that story isn't the story that everyone else is going to follow, because not everyone's going to be a professional programmer, right? But we do sports at school, not to make professional sports people. We do reading and writing at school, not to make professional readers, whatever that is, professional writers. So why are we doing computing at school to try and make professional programmers? It doesn't make much sense to me. And it makes it more difficult when you consider the fact that you go to these I mean, in the UK, right? We have this new, it's fabulous. The government, they created a new computer science curriculum, they pushed it out and said, we need to teach computer science as a science. It's as important as chemistry. It's as important as physics. And so what we'll do is we'll go and find all the programmers in the world that are interesting and ask them what excited them about programming. And guess what they said? Sorting algorithms. Right, and seriously, they made this, one of the biggest exam boards made this scheme of work that's going to get kids super excited about programming. All kids, not just kids like us, right, that were young, which we probably would get quite excited about sorting out. I certainly would have done. But everyone else, with titles like, have fun with sorting. Seriously. And the other one was like, kind of like it was like an anti-drug advert or something. It said, give binary a try, right? Because once you've given that, you're never going to go back. It's like, what is this? Like, so I was looking at this thinking, this is not the way to get more people engaged. This is the way to get people like me engaged. But we're already going to get engaged. How do we reach out to a broader set of audiences? And this also matches my experience of going to parties. Right? I mean, I don't go to parties very often. I've got kids. It's a shame. But if anyone has parties, please invite me. I'd love to go. And the problem is, you go to these parties. I don't know if you have this problem. I always had this problem. And they say, hi, what's your name? You say, Sam. You say, what do you do? I'm a programmer. And that'll be it. They're off. You're like, whoa, I've got so much to talk to you about, abstractions, and I've got really interesting ideas we're working on. I've got the system I'm building, blah, 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 blah. But they're not interested, right? So I lie now at parties. They say, what's your name? I say, I'm Sam. What do you do? I'm a musician. Oh, what do you play? Guitar? No, code. And now they're in it, right? So what I'm trying to do now is trying to provide people a way to actually have conversations about programming that aren't in a business context, right? At parties, just walking around the shops or going to visit your grandmother or whatever, right? We want to be able to talk about programming in those situations. And so I think Sonic Pi is one tool that's going to help us do that. And let's have a look at how this might work, right? So, yeah, this is the page to get it, right? It's totally free. It's totally open source. There's teaching materials, there's introductory materials, there's schemes of work. We have a community of loads of people, of artists, educators, coders. There's examples, there's talks, there's books, and then there's code, right? And the code makes music. I'm not going to press play because it's much more fun to do it here live, right? And so in schools, kids do this kind of thing, and they press the run button, and it obviously makes error, right? And actually, this is really important to point out because I don't know how many of you I've forgotten how hard it was to learn how to code. And a lot of people, they think that coders are always writing correct code. How ridiculous is that? And so getting people to actually start on a mistake is a good way to start and say, actually, this is the natural position for most programmers. We normally are in this error state because when we're not, we're on to the next problem, right? So we're always in an error state. And so we teach the first word in Sonic Pi, that's called play, because you're having some fun. Choose a number, and we can make a beep. That's pretty fun. So this is your first program in Sonic Pi. So this is something you can show your kids, you can show your grandparents, you show your parents. Look, you can make a beep. I'm like, whoa, okay, that's fun. And they say, well, okay, what other things you can do? Well, you can choose a higher number, and we can talk about notes and pitches, and really actually what we're talking about is numbers as a fabulous abstraction for things that can go up and things that can go down. And we use numbers to model all those kinds of things. And so pitch in music is a brilliant thing that can go up, or it can go down. It's not very loud, right? So if I make it a bit louder, let's have a try. I can change the amplitude. Always turn up the back there, like. Normally there's an interesting bass situation. Let's make it a bit higher note. Let's try that one. There we are. I did this in a cinema once in the Netherlands, and people were on their comfy seats like this, and this bass came out, because obviously in the cinema I've got insane bass, like this. So you can have fun. And also you can do things like super high notes, and you can start talking about the fact that the human ear can't perceive this kind of notes, but maybe bats could, or aliens if they existed. And I had this. I watched Twitter. People were talking about Sonic Pi all the time. It's really fun to see how they're using it. And there's this chap, and he was saying, yeah, I've been using Sonic Pi to make ridiculously high notes to really annoy my dog. Right, so this is a possibility. Now, so yeah, and you could also, I use it actually to test my family's hearing ability. Like, you keep notching the note up until you can't hear it, and it's surprising how your kids can hear notes and you can't. But yeah, you've got notes, that's fun. And the thing is then, you want to make two notes, maybe make a melody, right? So this is the point where perhaps the traditional computer science model doesn't work. You might think this is like a sequential program, and it is evaluated sequentially, but actually, I mean, if you want more information about how this works, come and find me later, and I'll really spend a lot of time talking to you about this. But the way this works is it sequentially works to the program, but then it asynchronously generates events, which are then queued up in a really well-timed system, which then honors the timing of these things. And if you look at the right-hand side, if I make it slightly bigger, you can see at time 0, I'm actually playing both those notes. So when we don't talk about time in Sonic Pi, and time is the most important and interesting thing when you're making music, then everything happens simultaneously at time 0. And you can make as many plays as you want, and this is how you make a chord, right? So 75, play 82, and lovely. So we need one more command, and that's sleep, and now we can spread the notes out, and we have the ability to make a melody, right? Now this is fun, right? Because I don't know if you looked at Logo, the programming language that Seymour Papert and friends were working on in the 60s and 70s. They had commands like pen down, pen up, rotate, and forwards. And with those commands, you could draw any picture. That's pretty cool. And kids, that's the thing, kids could draw any picture. Well, with these two commands, you can make any melody, any bass line, any riff, any classical piece of music, any modern piece of music, because most of Western notation really is which note to play and when to play it. Now, there's obviously a bunch of other stuff about timbre and sort of the feeling and all this sort of important stuff, but at its essence, it's really just which note to play and when to play it. And if you strip it down to these bare bones, you've got something simple enough that your kids can play with immediately, and they do, and it's huge fun. And the exciting thing to me isn't this, right? The exciting thing to me is, given this, what could we do as programmers to make it even more exciting? And that's the opportunity. And this is the important aspect, whenever we add new features on top of this, can we make them as simple as this? Right? I can teach this to a 10-year-old child. Right? I'm sure you could too. In the same way, you can get a 10-year-old child and show them a piano, and you can say, I can teach you how to play all the notes on a piano. It's not hard. Right? So you can get started. Now, the thing is, can we add more things? Can we get to the point, because obviously, right, if we go back to the beginning of the talk, this is me before, I'm not doing beep, boop, 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 right? This is not going to work, is it? It's not going to work. People aren't going to watch that, right? So where can you go with this? So I've got 15 minutes, and I'm going to really try my best the next 15 minutes to go as quickly as possible through the kinds of things you can do with Sonic Pi, not hoping that you understand it all, but hoping you see the possibilities, and that you hopefully believe me that every aspect I'm going to show you, I can and have taught to a 10-year-old child. Now, why is this important? Well, when you're in schools, obviously you're teaching 10-year-old kids, right? That's the thing. But when things are simple, and a teacher comes over, and the teacher isn't an expert in programming, or an expert in Sonic Pi, certainly, and in the UK, a lot of computer science teachers don't necessarily have degrees in computer science. And so we need to make systems that they can understand without having all that formal knowledge and the theory behind. And so in an education context, it's really important to have something simple. But also, when you're performing in a nightclub at 3 in the morning and you maybe had a couple of beers, you don't really want to be cracking open Emacs, right? It doesn't really, it's like there's too much cognitive load. The stress is intense. You want a simple system. And actually, it works out really well. So let's take this to some interesting places. So the first thing you can do, right, we've already seen I can modify these sounds. So I played note 70 and made it louder by amp 5, right? But some people often say, well, you say you can play any music with this. What about different durations of notes? Well, we have this synthesizer terminology in synthesizers, and it's the attack, decay, release terminology. I'll explain what it means in a second. But a release time is how long it takes for the note to fade out, right? So 3 seconds or 0.1 second, yep. And the attack time is how long it takes to fade the note in. So I can fade it in, or I can instantly hit it like this. And if you look at the documentation, so there's documentation for everything inside Sonic Pi, which is fun. There is a whole section on, let me find it, learning duration with envelopes. On envelopes, if I make this slightly larger here, you can sort of see that there's a graph here of sound going from quiet to loud instantly and then fading out over time. The duration of that line is the release time, and the fade in is the attack time. So we can sort of fade in slowly, and we can do this kind of thing. We can even make it last the same at some period of time in the middle, that's a sustain, and even do this decay thing. So we can do some crazy manipulations of the sound. You can even make those curves if you want to. So all these things are there. But really, release is mostly all you ever need, right? But what happens if I have like release 8? Now the thing is, at this point, that sound is really not very interesting. That's just a sine wave. It's the simplest form of sound you can create. It's just a basic sine wave. It's the fundamental frequencies. And most sounds, well actually, all sounds can be reproduced by adding a bunch of sine waves together. You just need to know which ones. And so the synthesis engine underneath this, something called SuperCollider, is really powerful tools for doing that. And I've built a bunch of different synthesizers which allow you to change the sound and modify it. So let's have a look at the Prophet sound. And I can down here, I could actually put a bit of maths in here, drop it down a couple of octaves. Maybe a bit more. Right, and maybe I can change the low-pass filter, cut-off value to be 70. Right. Now, so already, right, it's starting to get a bit interesting, and all I've done is change the synthesizer. I've had a keyboard, I've got different notes, I can switch around between them, and then I've got these different controls. And each synthesizer has a bunch of different controls. So the Prophet synthesizer has, you're not going to be able to see them all, but these dark gray areas over here, these are the synthesizer controls. That's 3, 6, 9, 12, 13 different controls. 13 different knobs you can tweak around. And each of them is named. And if you don't name them, you get the defaults. So you don't need to know about them. But if you learn about them, then you can start to really be expressive with the sound, the timbre. Now, there's something else I don't know if you noticed, but when I pressed the run button and it went pink, you heard the sound, right? Let's just try that again. Let's drop this down. 70. Yeah, and when I change the number and I press run again, you get another sound, right? And do the same again. But you notice that it didn't wait for the last one to finish before it started the next one, right? They overlapped with each other. So we already have a concurrent system, right? This is concurrent by default. And this is really interesting. So I can actually very quickly layer sounds on top of each other and build the sound up by just adding more threads into the system, and you can actually see that I call them runs in Sonic Pi. So this is run 59, 60, and 61, all completed. So they all have unique identifiers. But there's lots of other things you can do with the threads, which I'll show you in a moment. But it's important to realize we're already in a concurrent system. So we're teaching 10-year-old kids concurrency. And that's not hard. Concurrency is super simple. It's the sharing and coordinating the threads, which is the hard bit. And we're not doing that at all here, so it's not a problem. But what else can you do with this system? So I can do that. I can also trigger any pre-recorded sounds. So this is a really fun one. All the kids have never heard about this before. But if anyone here is over an age of sort of 30, you'll probably heard this sample in a variety of different places. Right, it's a very famous drum sample taken from the Winston Brothers in the 60s. It was put on a sampler CD, which was then handed around to a bunch of different hip-hop producers. And NWA used this sample in the 80s. And what they did is the samplers had this ability to take a sample like that pre-recorded drum track and not play at the normal speed, right? You could slow it down. And so you use a rate option in Sonic Pi to get that exact feel, and you can play it at half speed. And you can totally imagine rapping on top of this, right? And this is exactly what Dr. Dre was doing. But then you can go back to the UK, you go to Bristol, and you've got the drum and bass stuff like this, right? And then you go to London about 10 years later, and we've got a bit of that jungle going on. And it's just the same sample at different speeds, right? You can totally imagine all these different genres of music using the same sample. Now, what was really fun to me was I mean, that's just a very basic thing, and you can loop this around, right? We'll show that in a moment. But what people did as well is they took the sample, and it was like a WAV file, like a nice picture, and they chopped it up into each individual drum hit, right, manually. A bit like in the olden days, they used to actually have a tape, and you actually use scissors to chop it up. They were using sample technology to do this, but it was very, very painstaking. And then they would reorder the drums in interesting ways to make new music, right? And so I was thinking it'd be really cool to let 10-year-old kids do this. And so how would you do that? Well, first of all, you need a way to actually get this sample, Amen, which is a big data file. It's a buffer of floating point values which tell the speaker where to move. It's not really a structured data file, but treat it like a structured data file. Could I treat this WAV file like an array of drum hits, right? Where I could index into it, finding different onsets, and just pick out each individual drum. That would be really cool to be able to do, right? So I did that. And then once you've got that, you then just need a loop, right? Let's get a loop going. Loop, do, end, and you can sync for a short amount of time. And you can play the same drum, right? But wouldn't it be really fun to be able to pick a random one, right? We're already starting to make something that's a bit more interesting than the beats. That's fun, right? So then obviously you can combine that with randomized number systems. So I can like do some iteration in here, do it 8 times, and every 8 times I can random seed set it, and now I've got the ability to get a repetitive pattern out of it. So you can start to actually take these simple things and make it interesting. But so far, everything I'm doing is start and stop. Right? It's a standard programming model, right? Maybe you're going to write your specification, and then you're going to maybe write some tests, or maybe write some examples, then you run the code, you look at it, and then you see the errors, and then you then kill all the processes, you modify the code, you recompile or reinterpret, and you repeat. And every time you're repeating this iteration of development, you're stopping all the code, you're tearing down the system. You're taking maybe your database, and you're tearing it down, you're repopulating it with some values to then run your tests on it again. You're essentially tearing the system down every time you want to modify it and have a try. And that's what I'm doing here, right? Every time I press the stop button, it kills all the sounds, resets it so that I can start again. But imagine that, right? Imagine I'm in a nightclub, and we're dancing away, right? As you can imagine. It's like, I totally want to change the drums, right? Hold on. Let me just change the drums. Right. Sorry, you just can't dance at the moment. I'm just going to change it maybe to like, what should I change it to? Let's have a look. Breakbeat one, like, oh, we're good, right? Yeah, I can dance now. Oh, I'm going to change it a bit, sorry. Right, it doesn't work, right? And so I needed to think about how could I actually do this in a way that was fun, that allowed you to modify the code. But also, I had the problem of the fact that kids would also do this. Right? And they would want to have like a kick drum at the same time as this bass drums, right? So it's not going to work, right? And if I change the code around the other way around, you can instantly see why this is not going to work. I'll change the order of it, and I've just got the kick drum, right? Because I mean, this is a really interesting example. If you don't know why this doesn't work, have a look at it for a moment. We've got an infinite loop at the top, and the code just gets into that infinite loop between lines 3 and 6 and stays there forever and never ever gets to line 8. Right? And kids want to do this. They want to be able to do this. Now, the problem is, I said to the teacher, I observed a whole bunch, and within 2 hours, pretty much all kids get to this stage, right? And they want to have 2 things at the same time. And they say to you, how can I play the drums at the same time as the bass? Or how can I play the guitar at the same time as the drums? Or whatever it is, right? And so you go to the teacher and say, we need to teach them threads, because this is obviously going to solve this problem. We just have multiple threads running simultaneously. And the teacher says, no, we can't do that. It's not on the curriculum. And so you go back to this kids and say, well, the teacher won't allow me to teach this. You've got to wait till university. Now, this is funny, but it's also depressing as hell. Because when you have a child that wouldn't normally be programming, making beats with code, you've got them. They're there, they're interested, they're excited, and they're asking you questions. How do I do this thing that I want to do? It's not, how do I do a better sorting algorithm? It's, I want to make this thing. It's meaningful to the child. It's their thing, and they want to modify it. They're asking you to do it, and you say, no. Right? That's not good. We need to say yes, yes, yes. What do you want to do? And make sure whatever they can do more of that, right? To get them engaged, to keep them going. So the only way I could think about this is to basically cheat the system, like Matrix style. So you have to do this. As a programmer, the cool thing is we can change the code. We can change the system. We can change the rules. Now, I created this thing called a live loop. You give them names like foo and bar if you're a programmer, but if you're not a programmer, you might call this Sally and this Kate, right? Because they're now instrumentalists in my band. Right? I have 2 instrumentalists. Kate, she's playing the bass drum, bang, 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 and Sally's going nuts with the drums, right? And so if I run this code, they're both playing at the same time, so I have concurrency. Now, when I talk to teachers, I don't tell them about loop. I only tell them about live loop. I just say, in Sonic Pi, this is how you do loops, right? So the teachers don't need to know there's actually a concurrency going on at all. And the kids are able to automatically, without thinking about it, without having to ask the question, have multiple things happening, because they all write that original code, just the loop on its own. Now, the cool thing about the live loops as well is that I can comment stuff out, uncomment stuff, change the code a bit, change the loop back to the amen break, change it to something else. And start to modify it as it's running. Now, notice there's a few interesting things happening here. Like I'm changing the code, it's still running, so I'm live hot swapping the code, but it's also not missing a beat. Right? So even though I've got multiple threads, I've got concurrency. This is a weird, special concurrency, where it's not just 2 things running simultaneously, as normal concurrency is. These things are running on time with each other, like in a regular band. They know how to make sure they're in synchronization, lockstep with each other. Right? And in a way that you don't have to teach kids anything complicated. They just need to know about sleep, waits for some number of seconds, and they can then do the next thing and next thing and next thing, right? And so this live loop really starts to become the starting point of a performance. And when you see me later on at the party, this is exactly what I'm going to be doing. Now, I've only got a couple of more minutes. There's loads of other stuff I want to show you. There's lots of other things to think about. Like the important thing to realize is that professional musicians are using the system now to make new kinds of albums, new kinds of performances. And so this system has to really enable them. So one thing that professional musicians do is they work with external controllers. And so I have a MIDI device here, which has some knobs. When I turn the knobs, you can see on the right-hand side, I have all the events flowing through, and they go into I built like an event log system, which is persistent and totally ordered, and works with the concurrency environment, so that I can wait for the next modification of the event log or pattern match on that. So when I turn a particular knob or press a particular button, then I can trigger something and manipulate it. So that there's ways to actually get the code to interact with the real world, which is huge fun. And another thing you can do is you can use the well-timed nature of Sonic Pi to control external systems. So I'll just finish with this. So the fun thing here is I got this like a MIDI code. I can say play MIDI E1, sustain 0, so short period of time, and do this. I can then, let's just get rid of this. I've got an error because it's 0.1. Now, this is super exciting. I can see a flashing light. There you are. Let's prove it's working. And you can see that flashing light. Now, the thing is, this device now is making sounds, but obviously that's not connected to the speakers. But luckily, I have this cable here, which goes to my sound card, and my sound card can see the audio. So I need one more line of code, which is live audio, and then I can take any sound, a guitar, a microphone, a synthesizer, and play it through Sonic Pi. So let's call it a Moog synthesizer. So now I'm working with an external synthesizer, right? Huge fun. Now, the other fun thing is I can actually create another live loop, call it bass drum. I can synchronize it with an existing live loop, so whilst it's still running, I don't have to start and stop it. Synchronize it with Kate's sample bass drum house, C for half a beat. Right, we've got another thread starting in synchronization with the existing one. I can then start to manipulate it. I've got this octaves command, which I can make an arpeggiator out of this. And then I can live add effects. I can add some reverb, or crush it. Right, this is a lot of fun. I'm running out of time, but I'm on the minus time here. I don't want to stop doing that, and you shouldn't, right? Now I just finish with a small anecdote. So when I did the overtone thing, it was a Clojure thing, I gave a talk at the Clojure conference in the States. And it was great, people loved it, and they all went to their bedrooms in the hotel, and they all cranked it out and made some crazy sounds. But it was just... and no one got further than that, right? And what I'm hoping with Sonic Pi is that you can now go home with this. You can download it from the website, which is sonic-pi.net. Where are we? Here. You can click on the tutorial, and you can read how to do everything I've shown you, and much, much, much more. And this tutorial is written assuming you know nothing about programming or music, right? So if you know a little bit about either, you'll fly through. But if you don't, it's not a barrier to entry. Please, please, please share it with your friends. Let them know about it. Use it as a way to have a conversation with people you wouldn't normally talk to. Try and talk to people who don't look like programmers, right? And get them to see that programming is not just for business. Just like reading and writing is not just for business, right? Programming is one of the most, if not the most expressive thing that we've created. And it's tragic that we're still only using that incredible expressivity to make banking systems, right? So we should be using it to actually, as humans, work together and create new ways that we can express ourselves and share our ideas with each other. And I think music is a fabulous way to do that. Please, please share it with your friends, and come and see me perform later on tonight. Thank you so much.